Welcome everyone. Hack-free stuff here today. I'll be unboxing and conducting benchmark tests on the ACASIS EC-7352 external RAID enclosure with USB connectivity. I want to make it clear that this unboxing and review are independent and not affiliated with the brand. This enclosure is designed to house either 3.5 or 2.5-inch HDD or SSD. While the manuals are in Chinese, information about the GEM561 controller chip can be readily found online or on ACASIS' official website. The unit offers 4 array configuration. 1. RAID 0. 2. RAID 1. 3. Just a bunch of disks cognizing the disks as separate units. 4. Spanning urging both drive space into a single disk. Let's delve into the interface, which includes the DC power port, USB-C 3.0 port, power button, and fan. Positioned with the brand logo facing up, on the left side you'll notice the HDD on and HD2 LEDs, indicating disk activity through their blinking patterns. The exterior of the case, in a sleek gray color, is crafted from aluminum and features side slots for heat dissipation. However, the internal structure housing the disks is made of plastic and does not directly contact the aluminum case for cooling purposes. The European power transformer is included with the model I purchased, but there's also an option to buy the box without it. If you already have or plan to get a charger, ensure the output is 12 volts. For 3.5-inch disks, it's advisable to have 4 amps. For 2.5-inch disks, the requirement might be lower. The DC terminal measures 5.5 millimeters with a core of 2.1 millimeters. Included in the package are Phillips screwdriver and respective fixing screws. 2 screws for securing 2 5-inch discs in the lower area and 4 screws for 3.5-inch discs on the sides. The USB-C to USB-C cable comes with an integrated USB adapter for backward compatibility with older devices. By removing the 2 screws protecting the motherboard shield, you gain access to the cooling fan connection, which can be turned off for silent operation, if preferred. For benchmarking, 3 hard drives were used: a 3.5-inch Seagate 1 TB, a 2.5-inch Hitachi 250 GB, and a 2.5-inch Toshiba 1 TB. Individual disks underwent low-level, zero filling formatting before the benchmark testing. Before installing the disks into the ACASIS case, I conducted benchmarks on the 2.5-inch disks using a Ugreen USB box for comparison. The initial test involved the 250 GB Hitachi drive, evaluated using the Blackmagic Disk Speed test from macOS. During the test, there was a slight fluctuation in writing speed, where the test starts at 80 megabytes per second, drops to 77 megabytes per second, and then rises again. Upon further examination, I discovered that the disk had been formatted in HFS. As a result, the tests were exclusively conducted on this disk using that specific file system. Subsequent tests were performed using the exFAT file system for consistency. Now I will install the Hitachi disk in the ACASIS enclosure and leave the array configuration in JBOD. I will leave the box open, as no sensor prevents the equipment from starting without the aluminium cover fitted. Post-installation of the Hitachi disk in the ACASIS enclosure with JBOD configuration, I observed significantly higher and more stable speeds compared to the green box. The dedicated power supply in the ACASIS box potentially contributes to a consistent data flow. Next, I'll transfer the Toshiba disk to the Ugreen box and replicate the previous benchmark tests under identical conditions. Followed by testing it in the ACASIS box, showcasing similar superior speeds and stability as seen with the Hitachi disk in the ACASIS enclosure. Further, without removing the Toshiba disk, I installed the Seagate disk in slot number 2 using the same JOD configuration to observe the chipset behavior in macOS system information with multiple disks. System information indicated each hard drive with an additional digit in the media type name. The Seagate disk in the HD2 slot was associated with digit 0, and the Toshiba disk in the HDD1 slot with digit 1. Interestingly, the labels inside the box did not correspond accurately to the logical disks connected to the computer. By maintaining the disk placement in the box, but altering the array configuration from JBOD to RAID 1, both disks mirrored each other with a total size of 1 terabyte. This redundancy allows data restoration if one disk fails, with the chipset handling the data copying process. The disks required reformatting after the RAID configuration, appearing as a single drive. Under RAID 1 in system information, the extra digit in the media type name changed to the number 2. Notably, the writing speed was constrained and limited by the slower Toshiba disk. Additionally, I tested removing one disk from the RAID 1 array and placing it in the Ugreen box to verify whether data could be read. This test confirmed that the configuration is hardware-based within the ACASIS box, and software RAID is not used on the disks. What's great, in the event of a critical failure such as an ACASIS box failure, the disks can be placed in another machine in a plug-and-play way. I have a very positive impression of this enclosure. It proves to be incredibly useful for computers with limited AHA ports, such as Raspberry Pi, micro, or mini computers, especially for those requiring storage data redundancy. If this content has been helpful, please consider using the like button and subscribing to my channel for more informative content.